Welcome to the fourth video of the series Golang for Java developers. In this video, we shall go over the differences of various data structures like arrays, maps, sets in both the languages. The first line defines and initializes an array of integers in the corresponding languages. In both the languages, all elements of newly initialized array have default values. Because of this, second line prints 0 in both the languages. Also, you can see that setting, overriding and reading values from array are same in both Java and Go. Let's look at assigning new array variables. What we see on the right hand side of equal to in the first line in Go is an array literal. It has the length of the array, which is 2 in the example, data type of the elements, which is int, and the actual elements 5 and 5. In the given example, we initialize an array of 2 elements and assign it to an array of 5 elements. While you know this works fine in Java, the same throws a compiler error in Go. This is because array data type in Go includes the length of the array, and hence an array of length 2 cannot be assigned to an array of length 5. Let's look at another aspect of assigning array variables. In the given example, we assign an array to another one, override an element in it and print it. When we overwrite first element of the array array2 in Java, the change is obviously visible in array1 as well. We know that array1 and array2 are holding references to the same array object. Hence, the change is visible in both of them. But when we do the same in Go, the change is not visible in array1. First element of array1 is still 5. This is because when we assign an array in Go, a copy is created and that copy is assigned. Hence, the change is only reflected in array2. Also, note that copies of arrays are passed when they are passed as arguments to functions. Let's look at dynamic lists in both the languages. You are very familiar with the ubiquitous array list in Java. The equivalent of that in Go is a slice. It's like an array that can grow in size and does not include the length in its type. There are multiple ways to get a slice as shown in the Go snippet. First two are by slicing an existing slice or array using a half-open range. In case you don't know what a half-open range is, it's where elements from the beginning index to the end index are included except the one at the end. Third way is using make function by specifying the length of the slice. Last is by using a slice literal. This looks similar to an array literal but without the number of elements. We can see from the right snippet that setting, overriding, accessing an element at a position is same as arrays in Go. Go has a built-in function append to add elements at the end of a slice. This is how we grow a slice in Go. Note that append returns another slice that has the added element and does not modify the slice that is passed. You can see this from the values printed in right snippet. Also, since slice 1 does not have the appended element 3, trying to access that index panics in Go, which is similar to an index out of bounds exception in Java. Let's look at how slices look under the hood. A slice is like a subarray of an array that stores the pointer to the first element of subarray, the length of the subarray, and the length of the array from first element of the subarray. The leftmost picture shows the information that is encapsulated inside a slice. PTR is a pointer pointing to the first element of subarray. Len corresponds to the length of the subarray, which becomes the length of the slice. Cap is the length of the underlying array from first element of the subarray, which becomes the capacity of the slice. Middle picture shows how a slice created with make looks under the hood. In the given example, the array underlying the slice is of size 5. PTR of slice points to the first element of this array and the length of the slice is 5, as there are 5 elements in the slice, and the capacity of the slice is also 5, as the length of the underlying array from first element is 5. Right picture shows how a slice that is sliced from an existing slice looks underneath. The range specified is half open, which means elements at index 2 till 4 but not 4 are included. Correspondingly, the length of the slice becomes 2, as there are just 2 elements in the slice, and the capacity of the slice becomes 3, which is the length of the underlying array from the first element. The snippets show how we initialize a map in Go and its equivalent in Java. We need to specify the data types of keys and values to create maps. In Go, make built-in function can be used to create maps as well. Map literals can be used to initialize maps by specifying the keys and the corresponding values as shown in the third line. These snippets show how we set, override, access elements from a Go map. Note that this is similar to accessing elements in an array, but we specify key instead of index inside the braces. When a key is absent, default value, which is called zero value in Go, is returned. Hence, in the shown example, accessing value of the key absent returns empty string, which is the zero value of string. Here, we see how we delete elements from maps in both the languages. Go provides a built-in function, delete, that we can invoke by passing the map and the key we want to delete. Note that in case the key is absent in the map, delete is a no-op similar to Java's map.remove. Unlike Java, there isn't a specific inbuilt type to represent sets in Go. That behavior is achieved using maps. The snippet shows how we can leverage a map to make a set. Fun fact, hash set in Java is just a hash map wrapped inside a set API. Maps in Go also provide a way to check the presence of a key in a map. When we specify two variables on the left side of accessing a key in a map, like second line in the snippet, the value of the second variable, which is OK, specifies whether the key exists or not. You might think that we can infer the same by comparing the returned value against the zero value of the value, because Go returns zero value of value type when the key is absent. But that is not always possible, as we'll see. Let's store information about whether users are vaccinated as shown in the snippet. When we try to access this map, false is returned when the user is not vaccinated and also when an entry for the user is unavailable. We need a way to differentiate users that are not vaccinated and users whose data is not available. In such cases, we can use two-value assignment to determine if a key is present or not. That's all for this video. Thanks for watching. We shall look at Go's channels and its equivalent in Java in the upcoming video. Please don't forget to leave your feedback in the comments.